In this video, we're going to take a look at the reduction reactions of ketones and carboxylic acids. So essentially, reduction reactions for organic compounds are essentially the opposite of the oxidation reactions that occur with primary and secondary alcohols. So starting out with ketones here, a ketone can be reacted with, this is a reducing agent. And the reason we write it as an H in square brackets, it denotes that this reducing agent is essentially a source of hydrogen atoms. And so what's happening in this reaction is the ketone is gaining two hydrogens, one on the oxygen, one on the central carbon here. The CO, one of the CO bonds is broken, and so the ketone is going to get reduced back into a secondary alcohol. Now, when carboxylic acids undergo reduction, this is reduced to a primary alcohol via two steps. So the carboxylic acid first is reduced into an aldehyde. So in this particular scenario, it's a loss of hydrogen here back into the aldehyde with our reducing agent. And then our aldehyde is further reduced with our reducing agent back into a primary alcohol. So in this second reaction here, the central carbon here gains another hydrogen, and the oxygen gains another hydrogen, and then that CO bond is broken in order to create our primary alcohol. Now, unlike oxidation reactions of primary alcohols, the aldehyde that's produced here as an intermediate is an intermediate, but in most cases it can't be isolated. So it's harder to, or pretty much not going to happen where we isolate the aldehyde going in the reverse reaction, but we can isolate it if we go through the oxidation reaction. So if you had a carboxylic acid and you eventually wanted to land at an aldehyde, you'd have to go through the reduction process to the primary alcohol first, and then re-oxidize that back to an aldehyde. So it's a little bit more of a complex process to get there. Now, we haven't talked about the reducing agents. There are a couple of common ones. There's basically they're hydrides. So the first one is the lithium aluminum hydride, or LiAlH4. This is going to work for reducing all the different compounds here. So it can reduce aldehydes, it can reduce ketones, and it can reduce carboxylic acids. The second one is a little bit weaker. So sodium boron hydride, or NaBH4, only works for aldehydes and ketones, so not carboxylic acids. So it's a little bit weaker. You wouldn't use it, say, for this reaction here, but you could reuse it for the reduction of ketones or for the reduction of aldehydes. So those are our reduction reactions. That's it for this video. We'll see you in the next one.